Okay, so question number 9. Is xenon tetrafluoride polar or nonpolar? Explain your answer. Okay, so to find out whether or not a molecule is polar or nonpolar, we first need to draw out its Lewis structure. So the steps for writing a Lewis structure is to first find out the total number of valence electrons. In the case of xenon, xenon has 8 valence electrons, and fluorine has 7 valence electrons. There are 4 fluorine atoms in xenon tetrafluoride, so we multiply this by 4. And then when we add these values up, we get a total of 36 valence electrons. So now let's try to draw out the skeletal structure by drawing our xenon as our central atom. And then we kind of just draw the 4 fluorine atoms symmetrically around it. And we can show all of their lone pairs. Okay, so if we count out how many electrons I've drawn so far, with each bond containing 2 bonding electrons, then we only have 32 electrons in this structure, and I need 36 in total. So for the remaining 4 electrons, I'm just going to draw them as lone pairs on our xenon. Okay, so this is our final Lewis structure. And if we want to analyze its molecular shape, let's first count out the lone pairs and bonded atoms of our xenon atom. There are 2 lone pairs in total. And the xenon is bonded to 4 atoms. So we have 4 bonded atoms. So now let's use a VSEPR chart to find out the type of molecular shape we have. So we have 2 lone pairs and 4 bonded atoms. So this is on the next page. So when we have 2 lone pairs and 4 bonded atoms, we have a square planar molecular shape. Okay, so we know the molecular shape. And now let's find out whether or not a xenon-fluorine bond is polar or nonpolar. So to do that, we need to calculate the electronegativity difference between xenon and fluorine. So now let's look up the electronegativity values. So xenon is 2.6 and fluorine is 4. So this has an electronegativity difference of 1.4. So therefore we can say this bond is polar. Xenon-fluorine bond is polar. And we know that because its electronegativity difference is greater than 0.4, but less than 1.67. So now we can show dipole moments pointing towards the direction of the fluorines, since fluorine is noticeably more electronegative than our xenon, it creates these dipole moments. But if we look at the shape of our molecule, which is square planar, you can see that these dipole moments cancel each other out. So we can say that xenon tetrafluoride is a nonpolar molecule. So this is an example of how we can have a polar bond, but an overall nonpolar molecule. This is because the dipole moments cancel each other out. Due to the symmetrical molecular shape. And we can say up here that we have net dipole moment is 0. Okay, so the junior tutor said that a covalent bond is formed when two atoms share electrons. And there is equal sharing of the bond electrons, the electronegativities of the two atoms become equal, leading to the formation of nonpolar covalent bonds. The Lewis structure of xenon tetrafluoride shows that the molecule has a symmetric structure, therefore, dipole moment will cancel each other out, resulting in a nonpolar molecule. Okay, so they kind of talked about nonpolar covalent bonds, but xenon and fluorine is a polar bond, so I'm not sure why they just mentioned it. But the answer is still correct. And then I'll just kind of specify why. Okay, so I said the solution is correct. Even though the xenon-fluorine bond is polar, the overall molecule is nonpolar because the dipole moments cancel each other out due to the symmetrical molecular shape.